Yeah, okay. So in all the past presentation, we have talked a lot about different challenges that the digital society is facing. But a concern that has led space in this discussion is the environmental and ecological aspect of it. So in my presentation, I would like to go through this topic and analyze different aspects of the relation between artificial intelligence and the natural world. My presentation, wait, zoom just a bit. Okay. My presentation is based on 3 different quotes, which led to different themes of the subject in discussion. And this one is the first one, which says, as climate science, natural disaster prediction and recovery become more urgent, scientists are discovering the true potential of AI in the field. The effects of climate change are increasingly visible. Storms, droughts, fires, and flooding have become stronger and more frequent. Global ecosystems are changing, including the natural resources and agriculture on which humanity depends. The 2019 Intergovernmental Report on Climate Change estimates that the world will face catastrophic consequences unless global greenhouse gas emissions are eliminated within 30 years. Yet, year after year, these emissions rise. But environmental problems typically involve complex processes that scientists do not yet fully understand, and for which we have limited available resources. With advances in machine learning and deep learning, it's possible now to tap this predictive power of AI to make better data-driven models of environmental processes and improve the ability to study current and future trends. In the following diagram, you can see the different fields where it will be possible, or it's already possible, to apply AI models to solve different environmental problems, such as healthy oceans, water security, clean air, biodiversity, and conservation. And in particular, I would like to analyze 2 topics with 2 different examples. One concerning the land. I would say the hard soil is under pressure from pollution, population growth, and in particular intensive farming and other land usages. Its structure is not only compromised, but much of it is dangerously polluted. AI has the power of completely transform agricultural practice to make them safer for the earth and people's health. Machine learning combined with robotics can provide automated data collection and decision making to optimize farming processes. These systems can interact directly with crops to detect and act on the best time to plant, spray, and harvest, decreasing the need for fertilizers and pesticides, polluting the soil. This will make farming not only more efficient, but it will also lead to more organic, earth-friendly crops. And a concrete example of this is RIPA, which is a robot under development at the University of Sydney, equipped with a hyperspectral camera that has the capacity to perform mechanical reading, target pesticide application, and vacuuming of pets. RIPA can identify crops with poor health due to factors such as water stress, lack of nutrients, or the presence of pets. It can provide estimates of crop quality metrics such as size and predict yield and optimum harvest time. Such kind of system could involve a diversity of stakeholders. For instance, a mix of large-scale farming interests, small-scale farmers, agricultural equipment manufacturers, and chemical companies. And another big effect of climate change in the coming decades will be driven by hugely complex systems like changes in cloud cover and ice sheet dynamics. And these are exactly the sort of problem in which AI is great at digging into. In fact, AI can help unlock new insights from the massive amounts of complex climate simulation generated by the field of climate modeling. Starting from climate scientists' data-driven models, ML techniques may solve many problems that were previously challenging. These include black box problems, sensor calibration, and classification of observational data, and identifying pollutant sources in satellite imagery. For example, researchers from Rice University have developed a deep learning system that can predict deadly heat waves and winter storms before they happen. They trained a system on hundreds of pairs of maps that show surface temperatures and air pressures. These include the hot and cold spells that typically led to extreme weather events. Then each pair showed this condition in the same geographical area, but several days apart. After training, the system was applied to maps that it had never seen before and tasked making 5 days forecast of extreme weather. In the end, the prediction it produced were 85% accurate. And these are just small examples of what artificial intelligence can do to tackle climate change. And of course, there are many others. But what is interesting is that the focus on the integration of AI in this field is particularly pertinent to several stakeholders, such as companies, for instance, technology pioneer companies, but also companies leading in the industry, transportation, and building and construction, but also governments, so that they can assume a leadership role in generating opportunities for today and the future of their nation. And also university, research institution, and other educational partners, so that they can ensure that graduate students are ready to enter the job market with practical tools that integrate digital and sustainability. And in the end, also private investor, because obviously there is only one planet available to us, and it's up to each of us to take care of it. At this point, we could say that AI is the perfect solution for all the environment problems. But the reality is quite different. There are also several downsides linked to this technology, and it's interesting to see and investigate this aspect too, so that it's possible to have a better vision. And here we come to the second question, to the second quote, which says, "The artificial intelligence industry is often compared to the oil industry. Once mined and refined, data like oil can be a highly lucrative commodity. Now it seems the metaphor may extend even further. Like its fossil fuel counterpart, the process of deep learning has an outsized environmental impact." As we know, artificial intelligence produces startling achievements as computers learn to recognize images, converse, beat humans, and drive vehicles. But training a powerful machine learning algorithm often means running huge banks of computers for days, if not weeks. The fine-tuning required to perfect an algorithm by, for example, searching through different neural network architecture to find the best one can be especially computationally intensive and require staggering amounts of power and electricity. Since the damage caused by climate change becomes more apparent, AI experts are increasingly troubled by those energy demands. For instance, a couple of months ago, researchers at OpenAI in San Francisco revealed an algorithm capable of learning through trial and error how to manipulate the pieces of a Rubik's Cube using a robotic hand. It was a remarkable research feat, but it required more than 1,000 desktop computers, plus a lot of machines running specialized graphic chips, crunching intensive calculation for several months. The effort has consumed about 2.8 gigawatt hours of electricity, and that is roughly equal to the output of 3 nuclear power plants per an hour. And also, if we consider a large natural language processing model, the results are even more impressive. A research paper from a team at University of Massachusetts found that training a single large NLP model may produce 300,000 kilograms of CO2, which is also as much energy as the equivalent of 125 round-trip flights from New York City to Beijing. In addition, since the system needs a lot of power and therefore a lot of data, some of them can be stored in data centers. And it makes sense to have a small view about data centers as well. The Department of Energy of the United States estimates that data centers account for about 2% of the total US electricity usage. Worldwide, data centers consume about 200 terawatt hours of power per year, which is more than some countries. Forecasting by 2030, computing will assume between 8% and 20% of the world's electricity, with data center accounting for a third of that. The question now is, what are large tech companies doing about that? Unfortunately, a lot of them not that much. As in fact revealed by a Greenpeace analysis, only about 20% of the electricity used in many AI companies is so far renewable. However, this is not entirely accurate, because researchers are left to rely on voluntary information from companies without having access to the information they will need to make a full account of the true usage of technology's energy. It is therefore immediately clear how little information is available, and that is crucial as it relates directly to the perception and how much companies actually reduce emissions. For example, Amazon Web Services is the deepest set of machine learning and AI services, which serves close to half of the global market for cloud, meaning millions of business and tech companies rely on the platform for their online operation. Despite their obvious responsibility, they refuse to share data on their net emissions because they claim that making their emission data public could reveal to competitors a trade secret. Adding to their already sizable climate impact, Amazon in particular, but also other big AI companies, are aggressively marketing their carbon-intensive AI services to oil and gas, offering to help optimize and accelerate oil production and resource extraction. Amazon is luring potential customers in the oil and gas industry with programs like predicting the next oil field in seconds with machine learning. And recently, The Guardian examined the role of big tech in sustaining the market for fossil fuel, illuminating the massive amounts of money tech companies invest in organizations that actively campaign against climate legislation and promote climate change denial. Arrive at this point, I want also to say that my intention is not to show that everything behind this system is environmentally negative, but that something has to be done to stem these problems. And here it's where we arrive to the last quote, which says, "The good news is that some companies have certainly embraced their responsibility and are moving quite aggressively to meet the rapid growth with renewable energy. Others are just growing aggressively. There is a real risk that it all gets out of control. Policymakers need to keep a close eye on this." And in the following, I list some steps that has to be done to contrast this. The first one is mandate transparency. Regulators should require companies to provide full energy and carbon transparency. Information about tech companies' total climate impact should be available publicly and should be calculated in ways that inform customers and platform users about the impact of their own use of compute cycles and other infrastructural resources. Providing such information to regulators, the public, and cloud services is a first step towards building broader awareness, informing regulation, and incentivizing researchers and developers to make more conscious and accountable decisions. And second, account for the full stack supply chain. Understanding the energy use required to create AI and produce large-scale technical systems is only the first step. To account for tech's true environmental impact, we need a much broader view of the entire tech ecosystem, which means a clear understanding of the global supply chains that are required, including all of the extractive effects of the environment and the human labor at the significant waste produced. And third, make no energy policies analysis standard practice. Currently, AI is being introduced across nearly every policy areas as a strategic priority, without accounting for its climate impact. Here we see the importance of so-called no energy policy, which is a term describing policies that on their surface don't engage with climate or energy use, but still have a profound climate implication, which means AI energy and climate impacts should be calculated as a standard part of policy practice. And fourth, it's important to curb the use of AI to accelerate fossil fuel extraction in order to stop tech companies from accelerating oil exploitation and excavation by using AI systems. In conclusion, I would like to leave you with this sentence and also this question, which says, humans can do incredible things with very little energy. When we'll be able to develop systems in the same way? And also, what do you think? Will AI save the world or burn it?